Welcome back, everyone. Hope you guys had a nice break. So in this video, now we're on to 5.3. So we've been solving systems using substitution in the previous video. And we also did some solving with graphing. Now we're going to solve using a different method called elimination. Right? And the time that we really want to use elimination, right, is when we see two equations that are in standard form. And it's particularly a good method when you look at an equation and there isn't a variable that's easily isolated. So there's no like x or y that's already by itself or like close to by itself. 4x, 8y, negative 4x, 2y, those would all be tough to isolate. So for elimination, what we want is everything lined up. So see the x's, the y's, the equals, and then the number on the other side, kind of our ax plus by equals c, that standard form. All right, it's all set up in a way that's lined up for us. And what we like about that, right, is that if I were to add these together, I add the two equations. That's how we're going to use elimination. What you're going to notice is 4x minus 4x, or 4x plus negative 4x, is going to cancel out. So those are going to cancel out. And then we do 8y plus 2y is 10y equals 20 plus negative 30 is negative 10. And what I've done is eliminated. Get it? Because now there's no more x. That's why we call it elimination. We eliminated the x variable, so now all we have is y, and I can divide by 10, and then we get y equals negative 1. Now I'm not done. I have y, now I need to find x. So I can pick any equation from up above. I'll pick the top one, just because it's all positive. All right, and using that equation, I'm going to plug in. So we're going to get, let's see here, 4x plus 8 times negative 1, because that's what y is, equals 20. And then that's 4x minus 8 equals 20. Add 8 to both sides. We get 4x equals 28. Divide by 4, and we get x equals 7. So my answer here is the ordered pair 7, negative 1. X is 7, y is negative 1. All right, now we've done that, so I want you to pause the video and try the problem that you see at the bottom of the page. All right, check your answer here. In this equation, the y's cancel out when we add the two equations together. You get 3x equals 30, so x is 10. And I plugged 10 back into the first equation, and you end up with y equals negative 1. So 10, negative 1. All right, now sometimes the equations are lined up nicely. So we've got our x's, our y's, and the constants on the other side. But none of the variables when we add them together. So if I added these two equations together right now, nothing would cancel out. I'd get negative 9x, I'd get 4y. None of the variables would cancel out. And the whole goal of elimination is to eliminate a variable. We want something to zap away, okay? So I have to make an adjustment, right? And what I'm going to look for is a way to easily create a situation where the variables would cancel out. So I'm going to multiply one of the equations by a number, all right? And here's how I'm going to decide. I'm going to look and see, okay, if I want variables to cancel out, they have to be the same number but opposite. Okay, so that might be a good thing to write down. Same number but opposite will cancel. Will cancel. Okay, so if I look at the x's here, there's not so you look for the smaller one, negative 2. I can't multiply negative 2 by anything to get negative 7. But with the y's, my smaller y is 1. I like 1y because I can multiply it by anything to get 3. But I want the opposite, so I'm going to multiply to get negative 3. So I'm going to take that whole top equation, and I'm going to multiply it by negative 3. Use the dot and then negative 3. So that top equation, I'm going to draw a little arrow, becomes, and you have to multiply everything by negative 3. So I get positive 21x minus 3y equals positive 57, 19 times 3. And now I'm not going to change the bottom equation, so I'm just going to rewrite that. Negative 2x plus 3y equals negative 19. And what we like about that is now the y's are going to cancel. So let's add these together. I get 21x minus 2x is 19x. The 3y and the negative 3y cancel. And then 57 plus negative 19, 47, 37, 38. So that would be positive 38. And now when I divide both sides by 19, I'm going to get x equals 2. Sweet. So I got my x variable. All right. When I find that, I can plug that into either of my other equations to solve for y. So I'll use the bottom one, smaller numbers a little bit here. So negative 2, I know x is 2. So I just plugged in for x. Oops, plus 3y equals negative 19. Notice I'm just using that bottom equation, but I plugged in 2 for x. So now I know negative 4 plus 3y equals negative 19. That gives me plus 4 plus 4. 3y equals negative 15. So y, when I divide both sides by 3, would be negative 5. So there's my answer now, 2 comma negative 5, x comma y. All right, once again, pause the video and try this this problem at the bottom of the page. Okay, check your answer with the work that I did there. This time we had to multiply the top equation by negative 3, same number actually, and that way the x variables would cancel out. All right, let's try a couple more. Here on problem 3, what we're going to notice is there's not a number that I can multiply just one of the equations by, so I'm going to have to multiply both of the equations. So you can pick whichever one you want to cancel out. You could cancel out the x's, you could cancel out the y's. You just have to make the numbers the same but opposite. So for x, I'm looking at, we would want to get negative 15 and positive 15. For y, it would probably be negative 36 and positive 36. I think I'd rather go with the smaller ones, so I'm going to go with the x's. So I'm going to multiply that top equation by, let's say, negative 3, and the bottom equation by 5. All right, and then draw your little arrows and get yourself both new equations here. So the top one becomes negative 15x minus 12y equals, and then negative 30 times negative 3 is positive 90. The bottom equation becomes 15x. That's good because those are going to cancel now. 15x. And then 5 times 9 is, so minus 45y equals 18 times 5 would be negative 90. Okay, and so now I've got my two equations. I'm going to add them together. So negative 15x plus 15x, those will cancel out. We set that up. We made that happen. The y's, let's see, negative 12y minus 45y would be negative 57y equals 90 plus negative 90 is 0. Oh, negative 57y equals 0. That just means y equals 0. Okay, remember this isn't undefined or anything. It's saying what number times negative 57 is 0. It's 0. So y equals 0, and then I can plug that into either equation. Let's plug them into the bottom one. All right, so in the bottom equation, 3x minus 9 times 0 equals negative 18. That's 3x equals negative 18, so x is going to be negative 6. So there's my solution, negative 6 comma 0. Okay, go ahead and pause this one and try the bottom equation. Okay, and now you can see how you did. I multiplied the top by 5 and the bottom by negative 2, and that way I get opposites, but the same number for y, negative 10 and positive 10. You could have also done maybe the top by negative 5 and the bottom by 3, and that would get your x's to be the same but opposite. All right, more type here. So on number 4, what we're going to notice is that when I get these variables to be same but opposite, let's see, I'm going to do the x's to get them to be 10s and negative 10. So let's see here. Let's multiply the top by 5. That'll give me positive 10x. Multiply the bottom by 2. That'll give me negative 10x. Okay, so that's going to give me 10x plus 40y equals 30. And then on the bottom, I get negative 10x minus 40y equals negative 30. When I add these all together, the x's cancel out, the y's cancel out. If everything on one side cancels out, I get 0. And 30 minus 30 is also 0. So I get 0 equals 0. This is true. Okay, but true is not my answer. My answer is that there are infinitely many solutions. Okay, so whenever you get a true statement, that means there's infinitely many solutions. If you get a false statement, that means there's no solutions, because false means it would never work. True means it's always going to be true, so there's infinitely many solutions. All right, so take a guess at what you think the answer to this bottom one's going to be, but then pause it, try it out, see what you get. And there you go. This one is no solution. When you multiply, all you have to do is multiply the top by 2, and we get opposites everywhere for the x's and the y's. But on the right side, 20 plus negative 19 is 1. So we get 0 is not equal to 1. It's false. No solution. All right, that's all for this video. Thanks for watching.